Okay, now we're going to talk about series. All a series is if a sequence and you take the terms and you add them together. There we have a series. So it's kind of the same thing, except for we're adding all the terms together. So we'll get one number for the answer if we add them all. So one way we can write this, we call this summation notation. This is what we're going to do here. Okay, that's a big capital sigma, so that's summation notation. From k equals 1 to some number, however far we want to go. So if n is 10, we're taking the first 10 terms and adding them all together. So these are the terms and we're going to add them all together. Okay, and all that means is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, etc. all the way to a sub n. So this is a series and we add all the terms together. Okay, so let's write out with this. So what does this mean? So this the first one from the sum from k equals 1 to n of 2k. Well, we can write that as 2 times 1 plus 2 times 2. We're just plugging in. The first one, 2 times 1, we plugged in 1 for k. The next one, 2 times 2. Then the next one, 2 times 3, 2k. Then 4, we need to do 4, plus 2 times 4, etc. And it's just going to keep going. This just says to n, and we don't know what n is, so until we get to 2 times n. So we could write this as 2 plus 4 plus 6 plus 8, etc. all the way to 2n. Okay, so we've written out the sum. Let's write out the next one. So we have 1 over 3 to the k. So we're going to write all of our terms and put pluses in between them. So 1 over 3 to the first power plus 1 over 3 to the second power, which is 9, plus 1 over 3 to the third power, plus all the way to 1 over 3 to the nth power. This one doesn't tell us how far to go, so we're just going to go to n. Okay, now what if we have a specific index that we're going to? So this one is k equals 1 to 4 of 3k. So we're going to write term 1, 2, 3, and 4 and add those together. So k equals 1. This is the term we're starting with. We're starting with 1. And we're going to go to term number 4. So we have 3 times 1, 3 times 1, plus the second term would be 3 times 2, plus 3 times 3, plus 3 times 4. Now we're going to add all those together. So 3 plus 6 plus 9 plus 12. And then you could add all those together. And that would get you what your sum is. So here we've written out the sum, which is what this problem asks us to do. And then if you did add them all together, you'd have 9 plus 9 is 18 plus 12, which is 30. Okay, let's try another one. Let's write out the sum. So this time k equals 1 to 5. So we need the first 5 terms and add them together. So for the first term, we plug in 1. So 1 plus 2 over 1 plus the next term would be 2 plus 2 over 2, plugging in 2. Then we got to plug in 3. So 3 plus 2 over 3. Then plug in 4. So 3 plus 4 over 4. And then it asks us to go to 5. So this one should have been 4 plus 2, not 3 plus 4. I don't know what I was thinking there. So we plug in 4 and we get 4 plus 2 over 4. And then the fifth term, 5 plus 2 over 5. Okay, so let's simplify each of these. 1 plus 2 is 3 and 3 over 1 is 3. 2 plus 2 is 4 and 4 over 2 is 2. 3 plus 2 is 5, so 5 thirds. Plus 6 fourths plus 7 fifths. And then we could add all those together if we needed to. So that's how you use summation notation. We can just write out the sum of what we have, writing out those terms from whatever terms down here. This one says to start with the first term, all the way up to whatever term is up there. So this one, the first 5 terms of the sequence, and we added them together. Okay, so what if we have something and we need to express it using the summation notation? So here's our series, 1 plus 2 plus 3 plus 4 plus 5 all the way to plus 20. So we know we need a summation sign. We need k equals, we're going to start with the first term. And then how many terms are going to be in this sequence altogether? Well, we need to think about this. If we go from 1, 2, 3, 4, 5, all the way to 20, well, that's going to give us 20 terms. So however many terms we need. And then we can just write 1, 2, 3, 4, 5, we've talked about before, was just the sequence n. In this case, we're using k. So from k equals 1 to 20, add all these terms. So if we plug in 1, so this is how we think about it. If this was what we had, we were given this, If we plug in 1 for k, we get 1. If we plug in 2, then plug in 3, all the way to 20, which is what we needed. That's what it asked us to do. So here's our summation notation. Let's try another one. So this one right here, 1/2 plus 2/3 plus 3/4, and add all these up all the way to 13 over 13 plus 1. Okay, well let's see what our pattern is. We know we need a summation notation, and we're going to start at 1, so k equals 1 to something. Well, here we have, let's look at our numerators first. Our numerators go 1, 2, 3, etc. up to 13. The new denominators go 2, 3, 4, etc. all the way to 13 plus 1. So the numerators, looks like there'll be 13 terms then. The numerator starts at 1 and goes to 13. The denominator starts at 2 and goes to 14, so we have 13 terms. And then let's write our definition here as a fraction. So the numerator part is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so just k. And the denominator is just k plus 1. And it was kind of nice that this was written as 13 plus 1 instead of just 14. It helped us to see what was going on. So there we go. There we've expressed this sequence or series using summation notation. So let's do one more. This one is 1 plus 3 plus 5 plus whatever comes next all the way to 2 times 12 minus 1. Well, this kind of helps us give us an idea of what we need to do here, this 2 times 12 minus 1. So if there were 12 terms, then we're taking 2 times the term number minus 1. So let's see if that works for the first term. 2 times 1 minus 1, that is 1. That's good. How about the second term? So 2 times 2 minus 1, that is 3. So it looks like this is the term number right here. If we did 2 times for the third term, 2 times 3 minus 1, 6 minus 1 is 5. That gives us that term. Okay, so that kind of helps us. So we have our summation notation from k equals 1 to 12, because we're going up to 12, of 2 times k minus 1. So we look at our definition here, what's written out, and see what we can figure out. Find the pattern, just like we did when working with sequences. Find the pattern, write that there, and then how many terms do we need to include, and that's how we're going to know what to put for here. So k equals 1 to what number? In this case, to 12. Okay, so we talked about alternating sequences. So if we have an alternating series, it's really kind of the same thing, but we're going to have a plus minus instead of a plus 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 because we're alternating. So we have the -1 to some power. This one is k plus 1. You could use k minus 1. You could use k, whatever you need to have to help you here. So let's write out the first few terms of this one. So if we plug in 1 for k, we get -1 to the 1 plus 1 times 2 to the 1. Then we're going to add the next term, which is -1 to the 2 plus 1 times 2 to the k, which is 2, etc. Okay, we're just going to keep adding these all together. So -1 to the 1 plus 1 is +1 times 2, plus the next one will be -1 times 4. So it's going to go 2 minus 4, and then plus the next one, and then minus the next one. Okay, so this is an alternating series, just like we had an alternating sequence. Okay, so now let's write our definition, right? This was summation notation. So we're going to do this just like we have. So let the index k start at 1, just like we've been doing. So we have the sum from k equals 1 to some number. Well, how many terms do we have? 1, 2, 3, 4, 5. So to 5. And then how are we going to write this? So the first one we want positive. So let's do -1, 2. Well, what power do we need? We want the first term to be positive. So we're going to use k minus 1. Because if we plug in 1, we get -1 to the 0, which is +1. And then what do we have here? Well, we could write our first term as 1 over 1, if that helps us. It might. I don't know. So all the top numbers are 1. So times 1. All of our numerators are 1. And then what's happening in the denominator? In the denominator, we have 3, 9, 27, 81. So those are all 3 to some power. The first one, though, is 1. So how about if we put k minus 1 here also? Because we have 1 over 3 to the 0 is 1 over 1. And then the next term, 1/3, 1 over 3 to the first. Then we'd have 1 over 3 to the second, etc. So we have the -1 part, and then we have this part. So it's just like what we did with sequences, except for now we're writing it in summation notation. Now let's take the same one, though. I'm going to show you another thing. Instead of having k start at 1, let's have k start at 0. So, and we're going to have, instead, 1 is going to be our 0th term, I guess you'd say. Negative 1/3 would be the first term, second term, third term, fourth term. So we're going to start at 0. Well, why would we do that? Because we don't really have a 0th term of a sequence. But if we start at 0, sometimes it makes our definition a little simpler. So this time we're going from k equals 0 to 4. So term 0, 1, 2, 3, 4. So just a 4. Now what do we have? So we still need to alternate, so we have negative 1 to some power. Now this time, the first one is still positive, but that's our 0th term. So if we do negative 1 to the k, what do we have? We have negative 1 to the 0, and that gives us positive for the first term. The second one should be negative, so if we put in 1, negative 1 to the first power, that would be negative. So instead of a k minus 1, we just have a k. So it made that part simpler. Okay, now what about the rest? So times 1 over, again the numerators are all 1, so we can just put 1 over something. 1 over what? Before we had 3 to the k minus 1, but this time we can just put 3 to the k. If we put in 0, 3 to the 0 is 1, so we'd get the first term here, the 0th term, sorry. If we put in 1 for k, 1 over 3 to the first power is 1/3, that would give us that part. So we have a simpler thing here. We could write this as, and I think that this is how your book writes these instead. When I saw it, it looked like it was negative 1 to the k over 3 to the k. So they just wrote it as one fraction instead of the negative 1 to the k in front of 1 over 3 to the k. But it's the same thing. This one, the second one, just is a little simpler. So why would we want to use 0 as for the first term, the 0th term? I guess we could pretend it's called that. Just because it could make the definition simpler. Before we had k minus 1s in there, now we just have k's. It just makes our definition a little bit simpler. It doesn't matter. It either way means the same thing. We're just simplifying. Okay, and then the arithmetic mean. This is the last thing we need to talk about for this section B1. The arithmetic mean. So if we add the numbers together and divide by how many numbers there are, that's kind of what we think of as the average, the mean that we all know. It's called the arithmetic mean. And we can write this in summation notation. So that's what this is right here. So the mean, the arithmetic mean, which is what that line over there, over on top of that A means, is the mean. So we have the sum of all of our terms. So it's from k equals 1 to n of all of our terms. And then we divide it by how many numbers there are. So r times by 1 over n is the same as dividing by n. So that's just finding the average, but we're writing it in summation notation. So let's look at this one here. If we want to find the arithmetic mean of this the following list of numbers. So really we're just finding the average that we always find. So let me get that back up here. Maybe. Okay, so we're just finding our regular average, but we're going to write this with our summation notation this time. So 1 over n, okay, I just did the same thing again. 1 over n, which is 1 over however many numbers there are. Well, how many numbers are there? So let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 over 10, okay, times the sum of all of our numbers. So let's add up all of our numbers. 3 plus 6 plus 4 plus 3 plus 0 plus 0 plus 1 plus 1 plus 2 plus 5. Okay, so I just wrote out my sum. So this is in summation notation, the 3 plus 6. I'm just adding up all my numbers, then multiplying it by 1 over 10 because there's 10 terms. So let's simplify this. So 1 over 10 times 3 plus 6 plus 4 plus 3, so we're 16, 17, 18, 19, 25, if I added those correctly. So we have 25 over 10, which is 2.5 is another way we could write that. So what's our arithmetic mean? It's 2.5. Now this is just what we've always done for average. You add them all up and divide by how many there are. This is just a different way to write it. So this is the end of section B1 with sequences and series. We'll talk more about this in class and hopefully get all your questions answered.